Flow control valves are used to regulate the volume of oil supplied to different areas of hydraulic systems. In this course, you will be given an overview of the two types of flow control valves, as well as their application and location in a hydraulic system. This course is provided to help you learn why and where flow control devices should be used.
The function of the flow control valve is to reduce the rate of flow in its leg of the circuit. Flow reduction will result in speed reduction at the actuator. A flow control valve builds added resistance to the circuit, increasing pressure, resulting in a partial bypassing of fluid over the relief valve, or a de-stroking pressure of a compensated pump. This reduces flow downstream of the flow control valve. This circuit uses a fixed volume pump. To reduce flow to the actuator, we must bypass a portion of the fluid over the relief valve. As we close the needle valve, pressure increases upstream. As we approach 1500 psi, the relief valve begins to open, bypassing a portion of fluid to the reservoir. When flow control is used in a pressure-compensated pump, fluid is not pushed over the relief valve. As pressure approaches the compensator setting of 1500 psi, the pump will begin to de-stroke, reducing output flow. Flow control valves may be fixed, or non-adjustable, or adjustable. In addition, they may also be classified as throttling only or pressure compensated. The amount of flow through an orifice will remain constant as long as the pressure differential across the orifice does not change. When the pressure differential changes, the flow changes. Change in load or upstream pressure will change the pressure drop across the valve. Meter in is the method of placing a flow control valve in such a way that fluid is restricted to the actuator. In this circuit, without a flow control valve, the cylinder extends and retracts at an unrestricted rate. When we place a flow control valve into the circuit, this flow control valve will restrict flow to the cylinder, slowing the extend rate of the cylinder. The check valve allows return flow to bypass the flow control when direction of flow is reversed. When we move the flow control to the other line, the cylinder extends at an unrestricted rate. We can restrict the flow to the cylinder so that it will retract at a reduced rate. The advantage to meter in is that it is very accurate with a positive load. However, when the load goes over center, the load becomes negative or overrunning. The load is no longer being controlled by the cylinder. As the load overruns, it causes the cylinder to cavitate. Although meter in is usually the best placement for controlling a constant speed because it also dampens flow and pressure transients, it may be required in some applications to meter out. To meter out, we simply change the direction that the flow is allowed to pass through the reverse check. This will cause the fluid to be metered as it leaves the actuator, which is opposite of meter in. In this learning,